Good morning, everybody. Welcome to our second day at LoRaWAN live here in Orlando. I think it's a splendid day today, so I was opening the doors and bringing a little bit of the sunshine with me. So you're wondering why I'm wearing this yellow one today? I think some of you saw me yesterday wearing the blue one. Blue is the color from Zenner, but the yellow one, you all wear it. We are with the LoRa Alliance today. And I met up some guys yesterday I've met 7 years before when I had a first day with the LoRa Alliance as a member. It was in San Jose. And we had a nice yellow animal on the stage. It was a cow, and everybody was asking, what is the name of this cow? Hardly, I can't remember, but it doesn't matter, because we had the first LoRaWAN tracking device those days, and cattle track and mapping tracking, where's the cattle, was a massive thing there. And I know in the agriculture space, it's still a massive thing today. But now we want to talk about today about smart cities. And I'm here, I'm very looking forward to have two nice gentlemen with me here right now on the stage. They will show up and discuss a little bit about a smart city digital twin. And I welcome on the stage, this is Raza Jafri and Ali Benfattoum. Welcome, guys.
Thank you so much, Boris. I love how he brought the sunshine inside. It's good to see everyone here. So get ready. It's going to be an amazing, amazing morning.
So hi, everyone. Morning. My name is Ali Benfattoum. I'm with my friend Raza Jafri. So I'm a technical evangelist for IoT in the AWS IoT team. And we are going to present to you a city-scale digital twin that MetaWorldX built on top of the Smart Territory Framework. So what is first the Smart Territory Framework? Very quickly. This is an open source framework that we provide to our customers and partners to make it easier for them to create and operate scalable, efficient, and interoperable platforms. So all these words are important: scalable, efficient, and interoperable platforms. And it supports building applications in different domains: smart cities, of course, campuses, regions, utilities, energy, agriculture, smart buildings, and so on. And so there are some key benefits I would like to highlight, but I will dive deep a little bit more in details in the next slides. But very quickly, first it breaks down data silos, it enables platform interoperability, and it decouples data producers from data consumers. So why did we build this framework? We started with this mission our customers have, so cities, territories. They need to provide a better quality of life for their residents, to improve the lives of their residents, to improve the efficiency of their soft and hard infrastructure. And how they do that? They start with data. So they need to collect data from different sources, from different devices, from different applications, and they need to extract insights from these data. And based on the insights they get, they can then innovate, improve the services, and improve the lives of the residents. And it's an iteration process. But they need to have this holistic approach, because cities are like, you know, Rubik's Cube, this game? You try to make it right on the face, but actually you make it worse for the in other phases. So when you look at solutions like waste management, air quality, if you don't look at the traffic when you design this solution, then you miss the point. You won't have something that is efficient, because in the real world, everything is interconnected. So air quality is connected with traffic, traffic is connected with management, waste management, and so on. And what we see in the market, and why we decided to design this framework, is that we see hundreds, thousands of vertical solutions that are actually quite good, providing waste management, providing lighting system, providing air quality monitoring. But customers, from a customer perspective, from a city perspective, they can't orchestrate easily all these solutions, because each solution provider has its own way of structuring the data, its own way of storing the data, its own APIs, and sometimes even its own dashboard. I visited one city a year ago, and they had 5 dashboards they had to connect every morning because all the data were in different dashboards. So what we wanted to do is to break down data silos so cities can have in one place all the data they want to analyze, so they can easily link them together. So the second piece, the second challenge we wanted to tackle with the STF, STF is the acronym of the Smart Territory Framework, is platform interoperability. Cities, they want to work with an ecosystem of partners, of solution vendors, because there is no one vendor that can provide a solution that fits all the needs. So they need to work with an ecosystem of partners. And sometimes when they buy a big platform, an off-the-shelf kind of black box, they struggle to connect with very innovative startups like MetaWorldX, for example. So we wanted to provide a way to easily connect and help them have this vibrant ecosystem of solution vendors that they can work with when they want and how they want. And the last one, which is actually an important one for scalability, is to decouple data producers from data consumers. So data producers is everything that produces data. A sensor is a data producer. A fully featured platform is a data producer. And a data consumer is everything that will consume this data. So high-level API, dashboards, and so on. And if you take just, let's say, 10 different data producers, which is not a big number for a city scale, and only 10 data consumers, if you couple them, then your team will have to maintain 100 interfaces. This is not scalable, right? So we need a way to decouple both data producers from data consumers. So what we designed this Smart Territory Framework around a core component that decouple data producers and data consumers. And everything from the STF perspective is whether a data producer or whether a data consumer. And so we leveraged open standards called NGSI-LD and open source technologies from the Fireware ecosystem called the Context Broker. And we built this core component called the STF core that help customers easily plug in data producers and data consumers. And for what it means to build a data producer, it's quite easy. You have a data source. This data can be a LoRaWAN sensor, for example. This LoRaWAN sensor will produce some payload, and then the role of the data producer will be to get the raw data and convert it into this open standard that we use that is called NGSI-LD. And then on the other side, data consumer will always consume consistently these data because they are structured using these open standards. I will describe a little bit more in detail what are these standards. So the framework, this is a framework, provides key capabilities that customers need for almost every platform they build. It provides an IoT data lake, so you can have in a data lake all your data from all your sensors from heterogeneous sources. You can have them in one place, and regardless the way you fetch the data, you have them structured and standardized in one place. It provides a unified API that you can use to query the information, publish new information. You can use geoqueries, so if you are interested to monitor what's happening around some coordinates, you can do it. And you can also subscribe to events or to some events depending some conditions that you set. It provides digital twin capabilities, and we will show it in the demo, real-time dashboard, and also a way to manage your fleet of devices, regardless the operating model, regardless the connectivity, regardless the technology. So if you use, for example, a private LoRaWAN network and a public LoRaWAN network, you will have a central registry that in which you will find all your devices, regardless which network you use. Very quickly on the open standard we use, that is called NGSI-LD. So it provides two, I would say, specification. standards. First is the information model, so how the data is structured. So NGSI-LD represent information as entities. So an entity is something that exists in the real world, whether as a physical thing or a concept. And entities, they have properties. For example, if you use a LoRaWAN parking lot sensor, the property will be of the entity will be, for example, the sensor itself with its serial number, its battery level, and so on. And entities, they also have relationships with other entities. And so this parking lot sensor can be linked to the street. The street can be linked to the city and so on, and everything is an entity. And then on the other side, you have a standardized API. So you have a standardized way to query these entities, to publish these entities, and so on. And on top of this information model, we leverage an open and collaborative initiative called Smart Data Models that provide plus 900 data models in different domains, smart cities, smart agri-food. So for example, for a smart parking solution, you have a data model called Parking Spot that will actually help you structure the data in a standardized way. And we wanted to make it very easy to deploy this framework. So we use another open source initiative that AWS provides that is called Cloud Development Kit. So Cloud Development Kit provides you these capabilities to deploy your cloud resources using programming languages like Java, Python, and so on. So if you want to create a database, for example, it's one line of code, and then you have your database created. And so we packaged the STF in a CDK application, and we made it available on GitHub. So now you can go on GitHub, you search AWS STF, and you can deploy this framework with 2 lines of command, and you wait 45 minutes, and you have all these capabilities ready to be used. And then we work with partners to create some data producers and data consumers. And so, for example, we also published a data producer using some LoRaWAN sensors for different projects. We had one with a Bosch parking lot sensor. Another one, we actually published 3 different solutions using air quality sensors from MileSight, another one from Seal Studio, and another one from Alps. I know they are also on the marketplace, so look at their sensors. They are very good. And so we provide to the community a way to easily deploy this solution and plug them to the core of the framework. So very quickly, some examples. One is in the French Alps. So we had this company called SERFIM that had one request from a customer because during the summer, there are some accidents with hikers that are attacked by sheepdogs. And so they wanted to find a solution. And so what they did, they put some collars, LoRaWAN collars on the ships, not on the sheepdogs because it was too dangerous, but on the ships. And now they can geolocate the sheepdogs and send the information in real time to hikers so they can avoid to be in this area and not be attacked. So it's been implemented 2 years ago or a year ago, and now it's actually working smoothly in the French Alps. So I put the QR code if you want to watch the use case on YouTube. Another one is the city of Drancy. So they built a private LoRaWAN network using AWS IoT Core for LoRaWAN. So within days, they got their gateways connected to our fully managed offering for the LNS. And then they deployed air quality sensors, smart parking sensors. And the air quality sensors, actually, this is a nice use case because they, to reduce the spread of COVID-19, schools in France, they had to monitor air quality. So they deployed these sensors in schools for that specific use case. And then they realized that they could actually improve also the efficiency of the buildings because they realized that during the weekend, sometimes people left the windows open and they were heating for nothing. And the last one I wanted to show you is actually a live demo of what we built with Raza. So I pass you the mic and let you present this city-scale digital twin solution.
So thanks so much, Ali. So essentially what we were able to do, so with the LoRaWAN Alliance ecosystem and the Smart Territory Framework with AWS, we're essentially taking it a step further. So let's go back a bit. My background is in urban planning, and growing up in Canada, we had a lot of issues with our infrastructure. So we were always looking for ways that cities can be proactive rather than reactive. There's all this data that's coming into these cities from different providers, and it's kind of like in silos. So by the time that the cities have the ability to react to to a situation such as weather or risk mitigation, it's kind of too late. So what we started doing was over the last decade, each startup that I built, this is my third one now, and it was always around visualization, taking urban planning from analog into the digital space. So what we're about to see is these kind of environments require us to do either drone scans, LiDAR scans, low flying, then we use point cloud technology and we're able to build them. Or we use satellite imagery, which is getting better and better. We're doing a project right now in Egypt where the satellite imagery is so good that we don't even have to fly drones anymore. So essentially, what you're about to see is the first large-scale digital twin of the city of Toronto with live data. And a lot of that data is actually coming in from the Smart Territory Framework and the LoRa Alliance ecosystem. So whenever you open these environments, it actually opens up in the actual time and weather. But I changed the time a little bit because it's very, very cloudy in Toronto and I wanted a little bit of sun. So 4 degrees, obviously this is in Celsius. So we're going to start above the clouds and we're going to start going into the city now.
While you zoom in, I wanted also to share the story how we met, because we actually met only 4 months ago. And so we were working with Libelium to create a demo for the Smart City World Congress last November in Barcelona. And so we did that demo, integrated air quality sensors, LoRaWAN air quality sensors that Libelium has deployed in Cartagena in Spain. And so I had this 2D map of this solution. And then I met with Raza, and Raza showed me the amazing work he's doing around the city scale visualization of a digital twin. And then we said, let's build a demo for LEAP, the LEAP event in Riyadh. And so we did it in a few days. So we built Cartagena, and then we also did Toronto that we presented at LEAP. And the funny thing, to come back to my point of an ecosystem of partners and data producers and data consumers, the funny thing is that Libelium and MetaWorldX had never met before. And actually, we finished the demo, and that after the demo, I made the connection between MetaWorldX and Libelium. So that's also show how you can work with different partners and build this ecosystem of solutions.
Exactly. So I think it was meant to be, because as a tech startup, we were looking to tap into the ecosystem. And as many of you know, it's very, very difficult because in the beginning, you're building your team, you're basically trying to show your capabilities and build your MVP. And being from Canada, being from Toronto, it was very important for us to work with global providers of data and IoT systems. And when we met, we launched the company actually at the World Smart City Congress in Spain, where I was presenting on smart cities and digital transformation. And we had the CTO of Microsoft and Dassault System on the stage when we were basically opening this up to the world. And for a lot of large companies, it's amazing for them to see what startups could do, because we have the ability. We may not have the firepower when it comes to the dollars, but when it comes to agility and the ability to work in ecosystems and work with different providers to build these environments, that's where the startup ecosystem can really shine. So as we get into the city of Toronto now, you could see that the visualization is opening up. And obviously, I started early in the morning. But what really makes this powerful is the ability to see live data. So aside from the weather and the actual environment, what you're about to see now is sensor information coming in live. And I'm going to let Ali talk more about this.
Yeah, so like I described, you have data producers. In that case, you have air quality data, but you can imagine having every data that you can get. Traffic monitoring, waste management in real time, air quality like in that example, and you have this holistic view. So you can see in 3D all this information, and you can easily link them together, because if I provide you all these 100 different sources in a 2D dashboard, or even worse, on a spreadsheet, your brain won't be able to process all this data. But here, when you see, for example, the air quality and the traffic in a actually 3D view of the street, of a road, it's easy to say, oh, actually there is this impact, there is this connection between all this data. And I think that's why I really like this tool, because it shows the data. So I mentioned you have data, then you need insights, and you need insights with contextualized data. And for me, that's the perfect way of seeing how all this data can be connected together. And so that's for historical data and real life data. But then once you have enough data, you can also simulate, predict how your territory, how to design your territory in the future, but also predict how this will behave. For example, let's say you have an event, a big event in the city of Toronto, and you expect 400,000 people in a venue, for example. And then you can look at what would be the traffic congestion, what would be how to reroute some part of the traffic. So, for example, Raza, you are showing all the streets in this view.
For the city of, when we build these applications, and we make sure that the cities, the different departments can use it, they license it for roads, infrastructure, for urban planning, obviously shadow impact studies, and for the environment. So coming out of COP27, it was important for this city to be able to show how they're tackling carbon emissions, reducing their carbon footprint, and trying to get to net zero by 2050. So the ability to take a highway, for example, one of the big highways, for many of you have been to Toronto, it's called the Gardner Expressway. It's similar to what they had in Boston, the Big Dig, right? Removing that required a lot of engineering studies, but when it comes to environmental impact, for example, for the city, it was important to be able to remove the Gardner Expressway and actually show greenhouse gas emissions, how they would be impacted, how they would be reduced by doing that. So it's not just the power and the ability to essentially see what's happening right now. It's the ability to see what's about to happen, the simulation. This technology, and this is not even the final solution, because this is the beginning of what's about to come. With chat, GPT, OpenAI type of systems, you're gonna have the ability to be like, look, I want to invest in New York, I'm not from there, where should I invest in commercial real estate in the next 2 years? That's gonna be the power of the metaverse. So when we think about the metaverse, we don't look at it necessarily the way that some of the institutions in the United States right now are thinking about it. We're looking at the metaverse of the world for the world. This type of technology is going to help us, be light years ahead of any major issues that the cities can face. Just a quick example: they're now they have sensor data on seismic information that's coming into the city. They have information on the water levels, and all of that data, once we put it into the system, it can communicate with the different types of IoT data that we're bringing in. So how traffic congestion impacts air quality, how does the water level get affected by weather. So that's the type of insights we're going to want to look into more and more. So this is definitely the infrastructure and road network, the subway system, the bike paths. They also want to be able to use it to show the EV charging locations. Are they being utilized? What's the consumption like? The social impact is going to be important. So here is an example of all the parks, gardens, shops, malls, museums all around the city. And the really cool thing about bringing video game technology into the planning and engineering world is the fact that you can really do these simulations at a very, very high quality. Before, we didn't have the ability to build these environments to scale, but now we do because of high quality photogrammetry that's out there, the LiDAR scans, the point cloud. Now on everyone's iPhones, they have these LiDAR scanners as well. So you're gonna see a lot more, these environments getting a lot more interactive. And just to give you a quick example of what we were doing in the past in my last company, we were actually building the interiors of these buildings. So let's say there's a new building coming up in the downtown core. You'd be able to walk around, go in the elevator, see the shadow impact at different times, book the unit right there online. I just thought that we had to do something for cities. There was, growing up playing SimCity, a lot of us are familiar with that game. We always had the ability to see how certain decisions will impact the community, will impact the livability of the citizens. And I believe that now we're at that point where we can actually use this technology for real world applications.
Maybe let's take some questions, if you still have time.
Absolutely. If anyone has any questions, please.
I just assume we're supposed to use the mic for questions. As the city updates, is this something that is relatively easy to update, maybe adding new buildings, moving of roads, changing of utilities or facilities? How does that actually get updated? Is there a dedicated team for that? Is it fairly straightforward? How does that process work?
That's a really good question. So in North America, a lot of the cities are already built. There's additions, there's new buildings coming up. So because it's a SaaS model, which is why we have the ability to every 6 months update the digital twins when it comes to the visualization. When it comes to data, we can update that like on a weekly basis. So if there's new data coming in, those APIs we can plug in through the Smart Territory Framework. And for cities, let's say in the Middle East that we're working on, a lot of those cities aren't even built yet. So they're sending us the AutoCAD drawings, and we're making sure that we plot it into the exact longitude, latitude of the geographic location where it's being built. And essentially, it helps because when you have a SaaS-based model, it's a partnership. We have a partnership with our providers, and we have a partnership with our clients, the cities, for example. And we're continuously making sure that it's always updated.
I had a question. You mentioned leveraging video game technology. Is the rendering engine something like Unreal Engine, or is this by AWS, or what?
Yeah. So you're familiar with gaming, that's awesome. Yes, exactly. So the reason why we chose Unreal, so Unreal Engine is it's owned by Epic, and they're the ones who created Fortnite, the game. And the reason there's Unity, there's Unreal Engine, there's a few others. The reason why, so we can work with either or, our engineers and our environment artists. The reason why we specifically chose Unreal Engine, because I believe right now, it's when it comes to granular quality, when it comes to super high fidelity and reducing the polys, meaning making the frame rate as fast as possible, Unreal Engine's the way to go.
For cities who want to build something like this, is this public data that drives the content that we're seeing, or is it?
A lot of it is public data. The cities have certain internal uses that's protected within that department, but what you're seeing is definitely all public data.
Yeah, and most of the time, that's also what we have customers, they don't have yet data. LoRaWAN is always a good option because you can quickly start collecting data by deploying some private LoRaWAN network in a specific spot and getting some sensors. So it's, most of the time, we did it already with customers. It's a matter of days, sometimes weeks, to get the first data coming and start collecting data with LoRaWAN technology. So that's also.
I wasn't referring to the sensor data, but the geographic data and the city models. Is that Apple, Google, NavTech? Or
yeah, so the geographic data, that's a very good question. So like I said, if it's an area that, like the city of Toronto, we were able to, there's LiDAR scan that we did, low-flying LiDAR scan, and we were able to use point cloud technology, so it's literally millions of photos a second, and we stitch it together, and then we build it, and then we use AI for greater texturization.
Awesome, thank you.
Yeah.
How long does it take to make such a city?
So I think a few years ago when I started New York and Toronto, it took us a long time. It was very expensive and it was very difficult. But because of the capabilities of AI now, we're able to build environments like this in less than 2 months. Yeah. I think Ali mentioned it, Cartagena, Spain. They gave us a challenge.
We met for the first time 4 months ago, and we are today on stage with 2 demos, one Cartagena, one Toronto. So it gives you this time, an idea of the time it takes.
So we're at our 10th date now, and it's going really well. No, essentially, he's right. So when we met in Barcelona, I didn't even realize how quickly we could build it, because in the past I was building digital twin environments, especially in the prop tech world in real estate, and we were very, very focused on high quality detail. We don't need to have that level of detail for these environments, because these are larger environments and we want to make sure that the applications, when we deliver them, they're smooth. So these either rest remotely on a computer and then it's pushing it through the browser within the institution or the city, or we can upload it on a cloud service and then it gets pushed through that. And then you can have multiple instances, so multiple users visiting one environment at the same time.
And there are basically two things that make it easier and faster to build this kind of environment. Obviously, their technology, that's the first thing. And the second piece is because the data, like I said, is standardized. And so for them, they have a standardized API, and for them, they consume entities. If it's for traffic monitoring, if it's air quality, they consume entities. And then they just look at the type of the entity and put the data where it needs to be put. So it becomes very easy because they have a consistent mechanism to fetch the data. In real time, when the data arrives, they just show it and visualize it.
And what's happening now, it's actually, so the first step is building the digital twin, the environment. It doesn't mean anything. It's just a beautiful thing to look at if it doesn't have live data. The second step is taking the data that's out there, bringing it into the environment. Now it's a live environment. The third step is being able to control cameras, being able to control access gates. So in some of these projects we're working on right now in the Middle East, we just came back from LEAP, the tech conference in Riyadh. So the projects that we're working on over there, they have 2D maps for the controls of the cameras, for the controls of the access gates. They want to be able to control everything through the MetaWorld applications now. So to add that kind of integration is not very difficult for us. For Toronto, we already have all the cameras around the city linked into the application as well.
I think you may, in that last answer, may have answered the question I had already, but my question was about real-time data integration, and most of the GIS in the US anyways is built on ESRI, and if I have fleet vehicles pulled into my ESRI database already and we're feeding that data in, can you pull that into your platform in real time?
Absolutely. So that's the power of the STF framework. These guys, I gave him some air quality data of Toronto. Within 2 hours, he had it loaded into the Smart Territory Framework, AWS. And then within a few hours, we had it uploaded into our system. So if that data exists, especially if it's live, we can plug it into the system. We just have to design the asset in the way that you want it to be shown.
Yeah. So if air quality data is updating from, like in a classroom every 5 minutes, I could show that in your framework.
Exactly.
Every 5 minutes, it's going to update it within.
Yeah.
Exactly. So we have a partnership with IBM now, and they own the weather network. So the amount of data that they have, like we had to go through it and we had to be like, okay, this is relevant for Toronto, for example, severe weather, certain information that they had, we didn't even need to show. But that's something those are assets that are actually moving in the real world. You want to be able to track them on beyond a 2D map. So 100% that's something that's possible.
Yeah. And even if you have legacy systems, proprietary systems that cities already have, I mean, as long as you have an interface to get this data, you can get this data, standardize it in real time, or every 5 minutes you fetch the data you need, you standardize it, and then you push it into the framework. And from the perspective of a data consumer, a solution like this one, they consume it always the same way. So they don't need to update the way they consume the data, because they always consume the data the same way.
So we could see, like, for example, when we open these applications and it's early morning in any of the cities that we built or environment, you'll see carbon emissions are much higher during rush hour. Over here right now, you could see ground temperature. Wherever they have these IoT sensors, it's pulling in the live temperature. So by the water, it's closer to 0 degrees Celsius. Deeper into the city, it's warmer. So, for a lot of these environments, they're just blown away from the simple capabilities of open data. But imagine what we could do with data and insights that you already have. That's where I feel that you're going to get the most utility out of this. The other thing I wanted to mention was, especially being in North America and working with cities, we know that cost could be a big issue. For the longest time, I had problems working with cities. They didn't have the budgets for these kind of applications. But now, with MetaWorldX, we have the ability to build these environments and license them at a low cost to the cities. And you know, the lower barrier to entry allows them to have different departments using it, multiple users, and share the costs. For ECDev, they have a different purpose, and then for planning and environment, they have a different purpose. But the fact that we can have the same environment and leverage it across all these different divisions and departments, it allows them to be able to access it and afford it much better.
Yeah, just one quick question. Yes. You know what he asked. I'm just adding one more. I understand that it's a 5 minutes lag, right, between the real time and you present the data. Is it a pull or is it a push?
No. It's not 5 minutes. I mean, it's up to you. You can have real time. You can subscribe, for example, to with the STF. You have 3 ways of consuming the data. You have a REST API, so you fetch when you need to get the data. You have these capabilities to subscribe in real time to an MQTT topic. So at the moment the data is published, you get it. And you also can fetch the data from the data lake if you need to get more data, historical data, do some analysis. So if you have this real-time data producer, then your data consumer can also consume it in real time. So 5 minutes, it was just an example. You have the flexibility to say 1 hour, real time, or once a day. So that's you that decides how often you want to update the visualization.
Awesome. Go ahead.
Is it working?
It works.
If I put data from sensors from our company into your platform, what is the policy? Who is the owner of the data? How can I collect data from other sensors if I need a weather station? Or are you able to take my data? What is the policy?
No, that's actually a very good question. This is not our platform. This is a framework that is open source that you deploy on your own AWS environment. So you own the data, you control the data. I don't get access to any of the data. And you build your own platform on top of the framework. So this is something you use to build your platform, and this is your sensor data. You control everything, you own it, right? No one has access to this data. You decide who you want to share the data with, how you want to. It's your own platform, like you would build it on your own server.
And I can communicate to get data from a specific sensor I would need. If it's in the platform, do I see something? Do I get information of other sensors?
From other sensors?
From other vendors, other companies?
No. I mean, you have what you have access to, right? So if you want to publish data from other sensors that you would onboard, yes. If they give you an access to their, for example, their database, and you can fetch data from there, yes. But otherwise, no. You get access to the data you produce. So if it's an external data producer, even if it's a fully featured platform that exists on the market that you want to connect to the STF, you can do it, but you need to have this interface to this existing platform.
How much storage is the Toronto digital twin?
Oh, but yeah. So, good last question. Okay, so when we built this, it was. So when we built this, I think it was originally 30 GB or something. But on my, right now it's local. It's on my laptop. It's 2 GB, and yeah, we're able to. That's what I mean. With these larger areas, you decrease the level of detail, and you can really compress it a lot. And then if you push it through a browser, meaning people are teleporting to jumping around the city, you could do it on a website, and you don't even have to host it. We'll host it on the cloud. All right, last question.
Sorry, how do you confirm the location of the sensor, or how difficult is it to register the sensor on the GPS? Like, do you ever run into anomalies where you install a sensor in a certain location and then it appears somewhere else? Like, how does that commissioning work with the system?
Yeah, so that's on the STF side. So the framework, the information model we use in NGSI-LD comes with some defined properties for setting the location. So you have the coordinates. So when you onboard your devices, you set the location. If it's static devices, then the location stays the same. If it's dynamic, you can update it in real time. And so when they fetch the data, when they fetch the entity, it comes with its location. Every entity comes with its location, right? So at one point, if you make a mistake when you provision your devices, there is no kind of magic way to say, oh, it's not on the right position. But if you set up properly your devices, you onboard them with the location, the location, then even if they are static, every time information is produced, there is a mechanism in the framework that enrich all entities with its location. So even if you have sensors like we work with the Bosch parking LoRaWAN lot sensor, and they only send the status of the parking spot. They don't send the location, right? It's not part of the payload. But dynamically within the STF, it's enriched with the location. And when a data consumer consumes this data, it comes with the location. So they don't have to call another API to get the location of this device, or call another database to say, oh, this device, this DVUI is connected to this location. No, it comes with all the information you need.
Awesome. Thank you so much, everyone. Enjoy the rest of the day.